Trans-Pacific Floating Highway stretches across thousands of kilometers over ocean waves under natural daylight. Drone view looks down at multi-layered megastructure corridor with glowing yellow lanes and automated cargo platforms. Massive highway intersection displays clean concrete structures, green safety guardrails, and electronic display boards. Ultra-wide shot of highway marvel connecting distant artificial islands, showcasing scale contrast with deep blue sea. Highway structural underbelly shows gigantic floating titanium-composite pontoons anchored securely against water pressure. Industrial engineers in neon green vests and dark blue uniforms calibrate heavy mechanical valves on the structure. Field workers in neon green outfits and yellow hard hats operate automated control panels at offshore transit hub. Maintenance crew members in identical neon safety gear work with focused expressions to secure steel deck framework. Technicians in uniform route thick, heavy electrical power cables inside bright, hyper-detailed infrastructure terminal. Bustling open-air assembly deck filled with industrial workers operating synchronized machinery and heavy cranes under daylight. Chrome yellow crane lifts massive 50,000-ton concrete box girder to initiate main structural construction sequence. Primary automated conveyor line feeds raw, high-strength materials into industrial processing units inside coastal facility. Heavy hydraulic extrusion machinery stamps large titanium alloy plates, creating foundation shell for ocean highway. Automated robotic arms execute high-precision continuous laser welding on metal frame, emitting blue electric sparks. Massive assembly line matrix, where robotic gantry systems automatically position internal structural ribs into box girder module. Complete internal reinforcement frame advances down secondary automated production line for final inspection. Vast manufacturing spaces hum as giant overhead mechanical lifters transport rigid framework to ceiling deck. Automated high-pressure sandblasting units blast titanium alloy sheets to create clean texture for polymer application. Multi-axis laser scanners run along exterior surface of hollow box girder to track precise dimensional metrics. First layer of anti-corrosive marine compound is applied evenly across foundation plates by automated sprayers. Industrial engineers in neon green vests and dark blue uniforms actively install external hydraulic lines. Field workers in neon green outfits and yellow hard hats carefully align heavy internal reinforcement rings. Maintenance crew members in identical neon safety gear work with focused expressions to torque anchor structural bolts. Technicians in uniform work hard to lay out thick, high-voltage power conduits through structural main bulkhead. Bustling shipyard floor showcases rows of workers in neon gear performing quality stress tests on subassemblies. Chrome yellow hydraulic crane swings into place to prepare for lifting completed 200-meter box girder module. Industrial heavy-duty transport crawler engages multi-wheel tracking system to shift immense structural weight forward. Gigantic dry dock gates slowly open as deep ocean blue water floods bay to float massive module segment. Specialized ocean transport barge maneuvers alongside dry dock pier under natural daylight to receive load. Completed 50,000-ton titanium composite floating highway module is loaded onto transport barge to begin ocean journey. Specialized transport barge dispatches from shipyard, navigating slowly into deep ocean waters under clear daylight. Massive ocean swells hit barge hull, demonstrating high-strength stability of secured 50,000-ton highway segment. Secondary fleet of heavy-duty tugboats converges around main transport vessel to provide precise directional guidance. Satellite navigation screens in offshore operations hub monitor exact real-time coordinates of the cargo. Open sea convoy arrives at deep water construction zone, thousands of kilometers away from United States mainland. Industrial engineers in neon green vests and dark blue uniforms actively deploy underwater sensors. Field workers in neon green outfits and yellow hard hats carefully monitor hydraulic winch line tension. Maintenance crew members in identical neon safety gear work with focused expressions to calibrate dynamic stabilizers. Technicians in uniform work hard to execute preliminary alignment scans across open ocean surface. Bustling offshore construction site shows crew members in neon gear prepared for submerged deployment. Heavy-duty automated ballast valves on module open precisely, allowing seawater to fill internal stabilization tanks. Immense titanium-composite structure begins controlled descent, submerging below turbulent waves into calm water depths. Massive hydroacoustic positioning transponders emit high-frequency signals undersea to guide module into exact location. Underwater robotic ROVs maneuver through deep blue currents, tracking alignment plates with high-precision sensory arrays. Floating module reaches target engineering depth of 30 meters below surface, stabilizing in water column. Heavy ballast monitoring sensors confirm perfect equilibrium as second modular segment prepares for underwater alignment. Subsea structural docking brackets engage automatically, maintaining rigorous dimensional distance between colossal platforms. Massive deep-sea hydraulic thrusters fire continuously to micro-adjust horizontal drift caused by ocean currents. Laser telemetry arrays emit high-intensity green guide beams along seabed docking track to coordinate matching plates. Real-time acoustic transponder data streams into surface mainframe, updating geometric model every millisecond. Industrial engineers in neon green vests and dark blue uniforms actively secure auxiliary couplings. Field workers in neon green outfits and yellow hard hats carefully calibrate high-pressure hydraulic manifolds. Maintenance crew members in identical neon safety gear work with focused expressions to test emergency pneumatic seals. Technicians in uniform work hard to lock heavy-duty structural connector pins into bulkhead matrix. Bustling offshore control platform shows crew members in neon gear, verifying subsea connection telemetry. Primary interlocking guide shafts slide into precision alignment sleeves, absorbing massive physical kinetic energy. High-strength internal tensioning bars advance through modular core, preparing for final mechanical post-tensioning. Subsea isolation seals contract under external hydraulic force, forming airtight barrier against deep ocean. Dual-chamber drainage systems activate instantly, evacuating trapped seawater from central joint compartment at high velocity. Massive structural joint achieves zero internal moisture, establishing rigid permanent link between subsea highway modules. Massive post-tensioning hydraulic jacks engage simultaneously to compress structural tendons along modular subsea alignment. Extreme mechanical force is sustained continuously as internal steel cable matrices lock concrete printed segments together. Automated monitoring consoles record zero structural displacement, confirming initial modular connection phase is complete. Secondary heavy-duty external anchor lines are deployed swiftly from surface to stabilize mid-ocean construction zone. Deep ocean environment remains steady as newly joined highway section handles natural tidal energy. Industrial engineers in neon green vests and dark blue uniforms actively lock secondary seals. Field workers in neon green outfits and yellow hard hats carefully route external telemetry cabling arrays. Maintenance crew members in identical neon safety gear work with focused expressions to calibrate structural stress monitors. Technicians in uniform work hard to bolt heavy protective titanium plates over critical joint housing. Bustling offshore work platform features rows of crew members in neon gear conducting high-pressure hydraulic tests. Gigantic multi-axis robotic arms advance along exterior joint seam to apply secondary protective rubberized coating. High-intensity ultraviolet curing lamps activate automatically, instantly solidifying defensive marine sealant against salt water. Heavy ballast water pumps execute precise micro-adjustments, ensuring structural link remains at exact target depth. Subsea remote-operated vehicles utilize high-frequency sonar scanners to map structural integrity of completed assembly. Entire subsea engineering array transitions to standby power mode, completing technical sequence for mid-ocean connection. Newly established structural foundation undergoes immediate dynamic stability testing to evaluate resilience against undercurrents. Massive automated telemetry lasers scan exterior perimeter of locked joint to identify millimeter-scale positioning errors. High-pressure external water injectors test physical durability of primary rubberized compound sealing layers. Deep ocean blue water moves steadily around stable 200-meter platform as auxiliary internal subsystems activate. Digital diagnostic displays on maritime transport barge register optimal structural pressure values across joint. Industrial engineers in neon green vests and dark blue uniforms actively secure internal structural bolts. Field workers in neon green outfits and yellow hard hats carefully monitor heavy post-tensioning gauges. Maintenance crew members in identical neon safety gear work with focused expressions to realign auxiliary hydraulic couplers. Technicians in uniform work hard to route multi-channel fiber optic monitoring lines through bulkhead. Bustling offshore construction platform displays rows of workers in neon gear completing critical system calibrations. Giant chrome yellow hydraulic crane on auxiliary vessel begins lifting first upper deck highway reinforcement segment. Automated heavy-duty alignment pins lock into position on top deck to receive massive framework load. Thick structural steel plates are positioned precisely over internal core to begin surface roadway assembly sequence. High-precision robotic welding gantries track along transverse beams, generating intense blue electric sparks. Preliminary upper deck infrastructure is secured firmly, ready for continuous concrete printing gantry system. Massive continuous concrete printing gantry advances along structural steel upper deck framework with synchronized speed. Automated heavy extrusion head deposits dense marine-grade reactive powder concrete layers over dense mesh. Multiple laser levelers track liquid pavement surface continuously, maintaining absolute flat engineering cross-section tolerance. Industrial internal vibration bars consolidate wet compound instantly, eliminating micro-scale air pockets. Surface roadway base segment achieves immediate structural density as curing chemical agents activate rapidly. Industrial engineers in neon green vests and dark blue uniforms actively verify layer density. Field workers in neon green outfits and yellow hard hats carefully set secondary structural edge concrete expansion joints. Maintenance crew members in identical neon safety gear work with focused expressions to clear critical drainage conduit vents. Technicians in uniform work hard to lock high-strength perimeter steel rebar structures into position. Bustling upper deck construction zone displays rows of workers in neon gear, conducting specialized wet concrete scans. Heavy mechanical sprayers move steadily over newly poured pavement, distributing high-viscosity, waterproof polymer sealant membrane. Bright turquoise protective polymer compound creates airtight barrier shielding structural roadbed from harsh ocean salt spray. Gigantic multi-wheel asphalt laying machinery advances sequentially, laying down ultra-dense aggregate wear layer under daylight. Heavy vibration rollers compact steaming dark asphalt deck, applying heavy force to achieve final load rating specifications. Primary multi-layered ocean highway surface structure is finalized, establishing continuous land bridge pathway over open sea. Primary structural roadbed enters immediate fabrication loop as specialized installation equipment deploys automated guardrails. Heavy-duty perimeter steel frameworks are anchored systematically along margins to prepare for multi-signal electronic lighting. Automated conduit installation units guide thick, high-capacity optical communication lines beneath protective edge framework. Laser alignment transponders scan newly anchored perimeter boundaries to verify zero structural deviation across miles. Deep ocean horizon remains perfectly stable as surface superstructure achieves full mechanical integration. Industrial engineers in neon green vests and dark blue uniforms actively install signaling nodes. Field workers in neon green outfits and yellow hard hats carefully tighten structural support brackets. Maintenance crew members in identical neon safety gear work with focused expressions to calibrate automated toll matrix sensors. Technicians in uniform work hard to bolt down massive industrial power transformer enclosures. Bustling open-deck staging grid displays rows of workers in neon gear, verifying electrical circuit continuity. Giant chrome yellow gantry assembly vehicle positions heavy electronic overhead display matrices across main traffic lanes. High-precision digital laser meters automatically adjust overhead frame elevation relative to finished roadway surface. Thick structural aluminum alloy housing is locked into position to isolate vital control circuitry from saline atmosphere. Automated robotic wiring systems systematically link internal node network, generating minor blue electrical testing sparks. Completed overhead sensor infrastructure is fully energized, establishing primary monitoring field for massive ocean highway. Fully integrated overhead monitoring system initiates first localized diagnostic sequence to verify complete network stability. High-capacity optical transmission cables instantly transfer massive system status matrices to main data processing nodes. Precision power regulators manage energy distribution grids across upper highway section under intense natural daylight. Heavy structural dampening brackets along perimeter frame undergo rigorous mechanical stress testing using simulated acoustic vibrations. Clear ocean air remains perfectly calm as finished technological assembly stabilizes its core power draw. Industrial engineers in neon green vests and dark blue uniforms actively secure distribution hatches. Field workers in neon green outfits and yellow hard hats carefully test auxiliary transformer circuit switches. Maintenance crew members in identical neon safety gear work with focused expressions to realign electronic sensory masts. Technicians in uniform work hard to bolt down rugged, high-voltage junction terminals near roadside. Bustling roadside infrastructure bay displays rows of workers in neon gear verifying automated transmission links. Heavy automated painting gantry mechanisms advance smoothly along dark asphalt pavement to lay down reflective lane boundaries. Vibrant neon yellow and white thermoplastic compound cures immediately, defining primary functional transit corridors over sea. Massive structural expansion joints execute subtle mechanical compression tests to ensure flawless thermal elasticity under midday heat. Continuous laser telemetry units sweep entire highway width to map finished engineering surface macro texture. Complete Trans-Pacific Floating Highway structural pipeline transitions to operational status, finalizing monumental construction sequence. Heavy-duty infrastructure terminal undergoes immediate structural load tests as specialized automated vehicle convoys deploy across open lanes. High-capacity digital terminal arrays display real-time traffic logistics data inside vast enclosed multi-layered maritime transit station. Vibrant interior terminal display screens light up sequentially, signaling flawless infrastructure integration and system diagnostics. Final highway checkpoint layout remains stable under bright natural daylight, showcasing deep ocean blue and rich forest green accents. Completed Trans-Pacific Floating Highway stands as monumental engineering achievement, redefining global deep-sea industrial manufacturing infrastructure.